Today, we will see how can we solve a system of equation by the technique of graphing. So now the main idea here is that to solve a system of equation, we can graph both equations and then we're going to find the intersection. So that's really important here. For you to be able to solve a system of equation by graphing, all we got to do is just going to graph them and we're going to see where they intercept. And the interception is going to be the solution for the system of equations. So that's the main idea here. Let's actually put them into practice. So it says here, solve the following system of equation. And like I was explained on the main idea here, first we're going to graph the equations, which in the first example here, it's already graphed for us. So this is our system of equation. There are two equations here. That's what's called a system of equation. When you have more than one equation on the same set, then that's what we're going to call a system of equation. So here we have it. The first equation here, this will be our red line, y equals 2x plus 2. So if we graph it, we're going to get something like this. And now here in blue, that's going to be y equals x minus 1. So if you graph this, you want to get it this way. All right, so according to the main idea, first, we need to graph, which is already done for us. Now, the second thing that you want to do is we're going to be looking to where the graphs quote unquote touch, which is an intercept. So here we have it. Now, where do both equations intercept? So notice here at this point, exactly at this point, the red graph touches the blue graph, not nowhere else, just at this point. So here at this point, this is going to be our solution. The solution is right here. So now third step is just to identify the solution, which we already did. All right, so what is our solution? Is our solution -3 or -4? Nope, it's both. Because when we're talking about a system of equation, the solution is a coordinate point. So in this case, our solution is the coordinate point where both graphs touch each other, which in this case is -3, comma, -4. Because that is the coordinate point as to where both graphs touch each other. So not always they're going to give us a graph. So let's actually do one example where the graph is not being given. So what do you do when the graph is not being given? Well, you come up with your own graph. And for that, we're going to be using our calculator here. So here for our calculator, so what do we do here? Well, let's turn it on. So it's on. All right, so let's graph, and I'm going to classify it as the first equation as my red equation. Obviously, that's not red. All right, so that's my red equation. So how do you graph this equation in the calculator? Well, first you're going to go to y equals. And here where it says y1, let's actually put the equation that we want to graph, 4x plus 3. So for x, you can locate it here. So we have 4x plus 3. Now, if you press graph, yeah, you're going to get a line, and that is what we want. But when it comes to solving a system equation, you want to be as precise as possible. So we're not just going to make a line. This is just going to give us an idea as to how the graph should look like, but we're going to be using the table of values. So to get the table of values, we're going to hit second, and we're going to hit graph. Now this is the table of values for the first equation. So let's just get some coordinate points. 0, 3. So 0, 3. All right, so we get a point here. 1, 7. So 1, 5. Okay, so I'm going to use, so 1, comma 7. So 7 should be somewhere around here. And I don't know, negative 1, 1. Negative 1, comma negative 1. So negative 1, comma negative 1. All right. So actually, I'm just going to use this point, these 2 points, just to be exact. Because we saw that it was a straight line, and you only need 2 points to make a straight line. So we have those 2 points. We want to be as precise as possible. So let's use them now. So let's just connect our graph. And again, let me try to make this the same color. So let's make this red. So if we graph the first equation, I feel like that's fair. All right, so if we graph the first equation here, this is what we're gonna have. 1 second. What can I suggest for you to do is after you graph, just label your line. So this is the line that represents 4x plus 3. Okay, so now we're gonna repeat the process, but now we're gonna do it with the second equation here. Negative x plus negative 2, negative x, negative 2. So let's repeat it again. Press clear. Okay, we'll second quit. Good. So again, if we want to graph this equation, we're going to go to y equals. Now let's erase this because this is the previous equation. We don't want that. So we press clear and let's put the equation that we want. Negative x, negative 2. So this is a negative. So negative x minus 2. So we have that. Let's just press graph. So you are going to be graphing this line, but we're just not just going to draw a line that goes like this. So we want to be as precise as possible. And to be super precise, we're going to be using the table values. So we're going to hit second and graph. So here we have the table values. Let's get some points. So negative 1, comma negative 1. So there you have it. 0, comma negative 2. Yeah, let's just get another point. 1, comma negative 3. So 1, comma negative 3. All right. So we have it. Let me just change the color. Let me just connect the dots here. So it goes that way, that goes this way. Cool. And again, label your graphs. So this blue line, this is for the equation y equals negative x minus 2. Okay, so we already graphed it. Now what we want to do is to find the intersection. And it's clear that only at this point, the two equations touch each other. So this is the intersection, which in this case, because that's where they touch each other. So this is my solution. But we're not just going to say solution. We're actually going to write it out. So my solution, it's a coordinate point. What is this coordinate point? Negative 1, comma, negative 1. Perfect. So let's just finish it off with one more example here. So example 3 now. Again, it's not always that we're going to have straight lines, and you will see that in this example. So let's press second quit. Let's repeat the process. We want to solve for the system of equations. So what do? We graph it. So let's graph the first equation, which I'm going to call this the red equation. So we're going to press y equals. Let's clear this out. Let's do x to the second, which the second you can find it here. So x to the second plus x. Take away 2. So now notice that if I graph this one, it's a U shape. So, but again, we're not just going to draw a U shape here. We need to be exact. And to be exact, we're going to press second graph to get the table values. All right, let's get some points here. So I'm going to get negative 1, comma negative 2. So negative 1, comma negative 2. Okay, that's a point here. I'm going to get 0, comma negative 2. And I'm going to get 1, comma 0. Let me get 1 point on the left side. So let me get negative 2, comma 0 as well. All right. So if I choose these points, I'm going to have an estimate as to how my U shape is going to look like. So let's just draw it now. I mean, here we don't have a tool for that. Or do I have a figure for this? No, I don't. So let's just graph it by hand. So let's just connect the dots. And again, it should be some kind of a U shape. Okay, so that's my red graph. Just imagine that it's very well drawn. So now let's actually make it best. Let's actually do it good. So, all right, so that's fair. So let's actually graph our equation. So this is for y equals x squared plus x minus 2. So this is my red graph. Now let's do the blue graph now. So again, just clear it. Oops, second quit. Let's graph it. So y equals, clear that out. Let's put the new equation. So negative x plus 1. Oops, plus 1. So plus 1. Let's do the table values. So we have some points here. Let's choose some easy points. I see 0, 1. So let's choose that. 0, 1. And I'll also see 1, 0. 1, 0. I'm sorry, that's 0, 1, which is what we have here. All right, let's start it over. Negative 1 and positive 2. So negative 1 and positive 2. Now we got 0, 1. So 0, 1. We're going to get 1, 0. So 1, 0. All right, that's fair. Cool. So let's just connect the dots now. So we connect them. And again, don't forget to label your graph. All right, so the blue line, this is for y equals negative x plus 1. Perfect. So we have the red line, or the red graph, which is the first equation. The blue graph, which is the second equation. We want to know the solution for it. So let's see, where do both graphs intersect at each other? Well, I can see that they intersect here, or they touch each other. So this is what we're going to consider my solution. So now that we have our solution, all we got to do is just spell it out. Like, let's actually write down solution is, so here, my solution. It's a coordinate point. What is this coordinate point? That will be 1, 0. Perfect. So here we have it, the solution to this system of equations here. So now, for your entrance ticket, given the following graph, indicate the solution to the system of equations and explain why that is the solution here.